One of the real challenges for generating diesel power is getting enough air into the cylinder. Air, of course, is a necessary ingredient in an explosion. It's played a starring role in every single explosion created by every single diesel engine going all the way back to Dr. Diesel himself. In simple terms, the more air, the bigger the potential explosion, given equivalent amounts of fuel, obviously. One of the mysteries of diesel power, then, and one of the challenges to getting more power out of diesel engines, is getting enough air into the combustion chamber. It was really a vexing problem for the early pioneers working on internal combustion. They knew that more air meant bigger explosions, and bigger explosions meant more power, and more power meant, well, yeah, more power meant before too long diesel engines would probably be pushing around vehicles of a size simply unfathomable back in the day. You see, the limitation is a matter of pressure. With a piston traveling up and down inside a cylinder, there are really only two ways to get air in there. One is inhalation, taking advantage of the vacuum created as the piston travels down. It's really just a function of the amount of air that gets into the cylinder from whatever pressure is available in the atmosphere, and normally that's not all that much. And then there's induction, a process of pushing air into the cylinder. So, fairly soon after the invention of internal combustion engines, guys like Gottlieb Daimler, famously of the original Daimler-Benz operation, developed forced induction systems, basically ways of hooking up a fan to blow extra air into the cylinders. It's really ingenious, and it's great if it works. We'll use a high-speed fan to push air into the cylinder, drive up the air density, and create a more powerful explosion. But you can imagine the problem right away, can't you? If you just think about it for a second, how are you going to turn the fan? You can't just plug it into an electrical outlet. You have to have some method of turning the fan, a method that stays on board the engine, moves everywhere the engine moves, and ideally takes little to none of the engine's power to actually turn it. Now that's a fairly idealistic description of a fan that we might use to push air into the cylinder. Well, engineers back in the day came up with one of those solutions that makes a lot of us say, I wish I'd thought of that. They realize the engine is already throwing off an enormous amount of force every time the piston completes its stroke. Specifically, as it completes the exhaust stroke, it's already pushing gas out of the engine at a tremendous velocity. So how about just harnessing the exhaust gases to turn a fan that pushes fresh air into the cylinder? And the turbocharger was born. In its original form, that's the turbocharger. It harnesses the energy of the engine's exhaust to turn a fan that pulls in, compresses, and inducts fresh air. Now, just thinking about it conceptually, you can imagine how it's a great way to boost the engine's efficiency and increase power. It makes better use of the air and energy that's already available to the engine and pulls in new air to enhance the engine's fundamental explosion. Now, more recently, turbo technology has even been tweaked so that turbochargers can now be used to recycle waste energy, basically unburned fuel in the exhaust, so that one small device improves power, enhances efficiency, and holds one of the keys long-term to cleaner burning diesel engines. It's really quite an innovation. So now that we have an idea of what a turbo does and why it matters, let's move over to our DISTI virtual engine and explore a little bit more about where and how the turbo fits into the grander scheme of things. And there it is. We can see the turbo straddling the space between the air intake and the exhaust and plugged into the exhaust manifold. And we can see the crossover pipe that directs fresh air from the turbo into the combustion chamber. As the engine cycles through its strokes, it spins out highly charged exhaust, and that exhaust rushes out to the exhaust manifold into the turbo, where it spins the turbine-shaped fan that pulls fresh air into the engine. Now, if we pull the turbo out of the way, we can clearly see where it mounts on the exhaust manifold, and you can easily imagine how exhaust pumped out of the combustion chamber rushes into the turbo, where it spins the intake fan. Let's work through this one more time slowly. The air helps create an explosion, of course, and that creates exhaust. The exhaust gets pushed out the exhaust manifold and right back into the turbo. It's a very elegant cycle that makes a very efficient system. Now, the working technology is pretty sophisticated, of course, but the concept is really pretty simple. And as with all things diesel, if you can grasp the concept, the rest is a matter of adding details. And speaking of details, we took that turbo off, so we really should replace it. The turbocharger on the Cummins 855 modeled in our Disty virtual engine bolts back onto 4 studs threaded into the intake manifold. Let's put them back on and finish the job right. There. Now it's ready to go to work. And that's the turbocharger. It's a little bit of a mystery until you study it a bit, and then it makes perfect sense, right? Good. Next, we better figure out what to do with all that exhaust. We'll do that in the next video. Thanks. We'll see you there.